on my phone. Now earlier on I was doing a live stream and I was showing you about the power factor on the output stages. That's the input, 70 milliamps on the input on the high side at 30 volts. Now obviously there's multiple coils on here. There's 1, 2, 3, 4 output coils. Now you're going to find this quite interesting. What happens when I short out one of the output coils? Now you would expect that when I short out one of these output coils, that the output current that's going through the other coils, because each one is on a separate bridge rectifier. I'm actually using 1, 2, 3, 4 bridge rectifiers. I've actually got all 4 coils wired up now, which is something I didn't have earlier. Now this is what gets quite interesting. If I short out this one, if I can get it on, my input current has dropped to 40 milliamps, and my output current on the other coils is still at 44 milliamps. Take the short off. I've removed the short. It's gone up by about 2 milliamps, and the input current has gone back up to 70 milliamps. Now that's very, very significant. That is, yeah, very exciting actually. Now let's short out a different coil. I'm using this knife to short them out. Obviously if I short out one that's doing all the power driving, that one doesn't seem to make any difference. Oops, doesn't seem to do anything. Short out the other one. If I can get on the connection right. The other one doesn't seem to. I'm trying to get a good connection on it. Doesn't seem to make any difference, that one. My output current still 47. Let's shut out the other one. Not much of a difference. We're still seeing 47 milliamps going out. Short out the one that makes a big difference. Now on the low side, that's the meter over there. I'm going to show you what happens when I actually. Let's use a magnet to short it out, because the magnet should, I think, yeah, that works. So output current 44 milliamps. I've got a magnet right here shorting this particular coil on the output stage. Now look at the low side. My low side has dropped right down to 160 milliamps, right? Now remember that the actual circuit uses 50 milliamps, so we're actually only drawing 100 milliamps on the circuit now. So this unit here, even when it's not powering anything, uses 50 milliamps, as I'll show you again anyway. Right, I've turned it off. The unit's no longer running, and we're drawing 50 milliamps. Okay, so that's just by powering this thing up. Let's switch it back on again. Right, running again, and we're currently pushing out 39.7 milliamps. Let's check that. Magnet off there. Alright, it's weird. This thing really does some strange things. So we're back up to 42 milliamps. Now the low side, oops, I've gone back up to 200 and we're in the light. The low side has gone back up to 215 milliamps, 215 milliamps on the low side. Let's stick medical magnet back on that contact. Right, we're shorting that out. Output current 40 milliamps, and the input current's dropped down right down, as you can see, to about 160 milliamps. So that's really interesting, and we're still pushing out power. Look, on the other coils. So you would think, huh, that's odd. Yeah, when we're shorting out one of these coils, the one I'm shorting out is actually, which coil is it? White and green. I'm actually shorting out the I'm trying to show stuff. These pink wires, got the clips, the white, the green and the white. The green and the white leads are the same ones that are connected to where I'm shorting them out. So I'm actually shorting out the higher voltage coil, so the one that's got the most turns of wire on it, really, which is really strange, isn't it? Yeah. So, but we're still pushing out power on the other coils. So yeah, take that off, and my output has gone back up a bit. It's actually climbing slowly. This is another strange idiocracy. I can't even say the word. Weird thing that goes on with this thing is that the output current seems to climb slowly. Oh, I think I know why. It's because of my supercapacitors, probably, because they're actually buffering. So yeah, my output current's going back up. Curious and curious. But if I turn the device off, oh yeah, there's still some residual power from the supercapacitors. Yeah. Oh, I forgot about that. Yeah, so that's probably why it was still pushing power out. But what the main important part is, what's important is that the greater the load on the circuit, the less input it's actually using. So yeah, anyway, that's just a little bit more information on the way this thing's working. Yeah, so if I put this onto really slow frequency by flipping this switch like this, look at my current meter, it goes bonkers. It really doesn't like that at all. Anyway, thanks for watching.